Good morning. This is Ashok Kumar, Associate Professor from EC Department, and we are going to discuss about the electromagnetic interference and compatibility fundamentals. Initially, we are going to see about the basic definitions of EMI and EMC. EMI is nothing but electromagnetic interference is the degradation in the performance of a device or equipment or system caused by an electromagnetic disturbance, and EMC is nothing but the ability of the device to work satisfactorily in the disturbed environment, and at the same time it should not contribute any disturbance to that environment. These are the basic fundamentals of EMI and EMC, and we are going to discuss about the basic elements of EMI situation. So it has three major elements. The very first one is source, and next one is coupling path. The third one is receiver or receptor. The another name of your source and emitter, which is nothing but culprit, which is the source of interferences, and the coupling path is nothing but how the interference is coupling towards the receptor. Okay. Then the last component is nothing but receiver or receptor, which is actually going to be called as victim. So these are the basic fundamentals. Initially we have source, coupling path and receiver. The source is going to be called as culprit, and the receptor or receiver is going to be called as victim. These are the basic elements of EMI situation. Next we are going to discuss about the classification of EMI. So we have, based upon the operation, we have a wide variety of EMI, there which is nothing but radiated interferences and conducted interferences. In radiated interferences we have the narrowband interference and broadband interferences. This is the basic classification of our EMI. And the radiated interferences, we have the general system diagram here, which is connected with the power card, and which we have the two different subsystems. Initially we know that the system is nothing but the combination of subsystems. So in any subsystem, if any noisy component is presented, that entire system becomes collapsed. That means the noisy component in the subsystem is going to be acting as the interference source for the entire system. So let us consider the first diagram, which has the two subsystems, which leads to a complete system which is connected to the power card. So initially we are going to see about the radiated interferences. Radiated interferences, we have the radiated emission and radiated susceptibility. In radiated emission, what happened? Due to the presence of noisy component in the subsystem, it will be acting as the source of interferences. So the radiation from that noisy component will affect the nearby subsystem, so that it is going to be called as radiated emission. In this means the interference getting radiated from the noisy component. Then second one, which is nothing but radiated susceptibility. So this susceptibility is nothing but how long your system will be withstanding for the external radiation. That's what the concept represented by the figure 2. So in this case also we have the noisy component. See, you can see that in the diagram we have the interferences from the outside and coupling towards your noisy component, and which makes the entire system becomes collapsation. So the ability of your system functioning satisfactorily in the disturbed environment will lead to the radiated susceptibility. So radiated susceptibility is nothing but the withstanding capability of the system even though some interferences are present in the environment. So this is what about the radiated interferences. Then we are going to see about the conducted interferences. In this case, conducted interferences, noise or the interference is going to be coupling towards your system by means of current or voltage. So in this case we have two types: conducted emission and conducted emission and conducted susceptibility. So conducted emission, because of the faulty component or the noisy component present in the subsystem, which produces some unwanted fault currents or some leakage currents. These currents absolutely making some deviations in the performance of the subsystem. That's going to be called as conducted emission. Conducted susceptibility, externally some unwanted current forcing over the subsystem leads to conducted susceptibility. So whatever it may be, the system should have the ability to work satisfactorily in the disturbed conducted interferences scenario. Then we have the, based upon the caused problem, it's going to be dividing into two types of system: intra-system and inter-system interferences. So intra-system is nothing but, let us consider we have wide variety of systems. In that environment we have n number of systems. If any system is going to be acting as the interference source, the nearby system will be gets affected. This is going to be called as intra-system. Inter-system, nothing but we have wide variety of systems. In a system we have a subsystem. In that subsystem it makes some fault in the individual subsystem, will leads to some drawbacks in the entire system. That's going to be called as inter-system and intra-system EMI. Then we have here the example they have given you: intra-system, power supplies, radiation, radar emitters, and mobile radio transmissions. Everything is going to be acting as the intra-system EMI. And then inter-system EMI, you have the computers, power lines, radar transmission, everything acting as the inter-system EMI. These are some examples for the intra-system and inter-system EMI, and the effects of EMI is listed here. and this is the basic mechanism of interference. So here this mechanism represents that how the interference travels from source to receptor. As we know that the source is the origin of the interference. Because of this interference, some of the nearby equipments are affected. Those affected equipments is going to be called as receptors. So receptor is nothing but actually a victim. So there are 4 different paths the interference takes to reach from source to receptor. The very first one is direct radiation from source to receptor, radiated emission. The path 2 represented in this diagram, direct radiation from source to the cable of the receptor, is going to be called as conducted emission. Then third path which represents the cable to receptor. So this also kind of radiated interferences. Radiated interferences from cable of the source to receptor, and finally the last path, fourth path, representing that the interferences from cable to cable, conducted interferences. So actually this mechanism shows you that whatever it may be the interference, it will take the different paths to travel from source to receptor. Overall the conclusion is radiated emission, conducted emission, whatever it may be the source and receptor. These are the basic mechanism of interference which we discussed. Then last we have the sources of a wide variety of sources. We have the different types of natural noises and man-made noises. We have plenty of examples as per the concern of system and as per the concern of circuited components. Natural noises, ultimately we know that terrestrial and celestial noises constitutes your natural noises. And these are some of the examples, wide variety of cases where we can feel the interferences in day-to-day activities. Thank you.